My name is Dror. We worked on the EIL, and I'm going to present the EIL SDK. A quick overview. I know you probably heard it. EIL is a cross-chain protocol to do decentralized token transfers. And the SDK is the tool that you, as a developer, can create an operation that spans multiple chains, and it abstracts away all the logistics of moving assets from between different chains. So this is the EIL SDK. You can download it now, and you can download it later if you want to try. I will try to explain the APIs, to explain how it works, and maybe walk through and see it, the application runs. Okay, what is the SDK? It is a TypeScript library that lets you do everything you need to do to make a cross-chain token transfer with the protocol. This is an overview of the protocol. Basically, the classes that you're running with the protocol. You start with the SDK. The SDK is the wrapper, the overall wrapper that you work with. Now, in order to create a cross-chain operation, you bring up a builder. You create a builder contract. And from it, you spawn multiple, what we call a batch builder. A batch is a set of operations that you run on a single chain. We are using ERC 4337, obviously, underneath. So each batch is eventually a single user operation that runs on a single chain. So you create multiple batches, one for each chain that you want to run. Within each batch, you run an action. An action, it's a single call. Again, it's a bit abstracted. We will see it later. You can have a simple method call, but we also a higher level like token transfer. And I'm not sure if it's here or here. They created with the Stitch project, if you've seen yesterday, they created multiple DeFi actions like I want to lend, I want to use specific protocol. But basically, an action is a wrapper for a method call or a set of method calls that you can use. Once you created, you use the cross-chain batch builder and you create multiple batches, it's time to execute them. So you first build all the user operation out of these batches, which requires checking that there are providers, checking that the balances across the chain, and then you hand out the output to what we call the executor. The executor is a contract that runs these user operations, like executes the first user operation, waits until it's executed or failed, probably executed successfully, and if this user operation requested a token transfer to another chain, then it waits for the tokens to appear on the other chain through the bridge and execute the next user operation. So basically, it wrapped everything, but it's a single execute call. We'll see that. These are the core contracts of the SDK itself. We have multiple helpers. Everything is multi-chain. So we have a multi-chain contract. It's a wrapper that around a contract that can have different, either the same address or different addresses across different chains. And obviously, the most useful one is a multi-chain token. We have one in the sample. We see we have USDC on multiple chains, and we also have USDT on multiple chains. And you can bring up your own object with multiple addresses. The idea is that you usually work with this multi-chain object, and you don't really care its address on the current chain, because when it is added to a batch, it will use the right address. And of course, the account itself, you as a user have an account, so it is a multi-chain account. It's a wrapper around a smart account, and it manages all the interaction within the different chain, manages the nonces on the different chains, everything when it needs to deploy and everything.
If I may contrast it with how you used to work with user operations and event transactions before the EIL SDK. So you would need to create an instance of a smart account for every chain you are working on, and the same it will go for a token. You would have a set of configurations for every token on every chain, and the same goes for an action. You would have to build a batch action if your smart account supports it for a chain, and then you would have to repeat this action again for a different chain. So here we allow you to do the building once and signing once using the appropriate classes and appropriate APIs for the cross-chain operation. And the difference is cross-chain is when you actually intend to do something across the chains, and the multi-chain stores the data that spans multiple chains for you to use in your application. So.
Okay. And we are talking at the API level, but at the UX level, obviously, the most important thing that a multi-chain smart account we want you to do is sign at once all the user operations. A simple one, if you have a private key, it's very easy. Sign for all, because there's no UX, so there's no UX even to sign multiple times. We did some work with Ambire, so you will be able to do a single signature on a single dialog to sign all the user operation, and then you can run them through. Okay, I'm now going a bit deeper. I'm going to see to show how we're using the SDK. The first thing you do is you bring up the SDK. It can receive parameters in order to define what chains it is connected. At the moment, it is connected to we brought it up on a testnet, actually on a Tenderly-based testnet. So it has 4 networks. It supports Ethereum, Arbitrum, Optimism, and Ethereum mainnet. But you can bring it with more. Right now, it is built with these 4. I create my account. I create my multi-chain smart account, and I pass it the owner that will be the entity that is signing for them all. And I create a builder. We'll see in a moment how I use the builder to create all the batches inside it. And also we started for this sample, we created an instance of USDC. I think I put it into the file, the token file, which actually I didn't put it into the slides, but basically it's an array of chain and address. I need a list of chain and addresses. This is what I need for a token file. From the SDK, it connects to the connected networks that the SDK is currently supporting.
If I may, I don't know if the future slides will elaborate on it. We can see here that we create an account from the private key. It's like one example that would require your application to have a direct private key. But the account class here, when it's passed to the builder, it's just an interface. So either you can implement it or wallets can implement their own account wrapper, and we will be shipping with a number of account implementations where it can be using your injected account for sure. So you need to prepare the multi-chain smart account with the appropriate API, and then you pass it to the builder, and then this account will be used to control your multi-chain execution.
Yes, the presentation I built around a command line application that uses this multi-chain account, and actually it's a simple one. It signs separately using the owner. We do have, as I said earlier, the Ambire account that can connect underneath, and it has a UX, and then it prompts you once to sign all the user operations. Okay. Now we're seeing a batch. This is a sample batch that we created with cross-chain builder, because if I show the API of the cross-chain builder, it's a single function, start batch. So in this example, can you see them? Yeah, you see my mouse. I started the batch on a specific chain, let's say Arbitrum, and I want to perform some actions on this chain. We'll go deeper about the actions. You can see I added a transfer action. I give the token. Again, it's a multi-chain token. I don't care about the address, because the batch will run on a specific chain, so it will know what address to use. I forgot to fix it. Of course, I cannot transfer to zero address as recipient, and I specify the amount I want to transfer. It could be, this is a very simple, simplistic example. Of course, you probably want to do some DeFi application. You can also call some, make a function call on whatever contract you like, and pass it parameters. And now we're getting to the juicy part. I want to perform some operation that will go to a different chain. This call with the voucher request. The model that we have is that you make a voucher request. It's a call you make on chain, so it is an action. Basically, it becomes an action just like any other action, like tokens transfer or whatever. A voucher request saying, I'm locking these tokens on this chain. A list of tokens, here is one. And I specify what the destination chain I want these tokens to come. This is a call I make to the contract of the EIL on chain. And it will make a call and lock this for a period of time, like 1 hour, on chain. This is also the end of the batch. Usually, transfers you usually do at the end of the batch after you're doing some other stuff. Should have written a better example before that, like swap something. So I end the batch and I start a new one. The next batch, not surprisingly, is running on the same destination chain of the voucher. This is a simple flow. I go one after the other, but a flow can span more than two. And I started the batch of the destination chain. And I specify that this batch should use the above voucher. I have the ID of the voucher. I specify I use that voucher. This will tell the SDK when we build everything that the second use operation first can only run if there is a voucher, if it received all the transaction. It cannot be submitted on chain because everything it executed later, there's no another action in the example, but can depend on the fact that the tokens were transferred, the amount will be there. It is impossible to execute this code without these tokens arriving because using a voucher means I expect all these tokens to be here. It is impossible to do it otherwise. And another thing it means that we don't deeply say within this presentation is about gas fees. When I created a voucher, I also said, and yes, I will pay gas using the first token I specify in this request. The example here is still using 0 gas fees. We don't deduct this value, but it should. And then it means that the second user operation that runs on the second chain is already prepaid for. Like the fact that it can use this voucher means that the provider that I'm using agreed to pay for this voucher, and I'll get the money with the voucher deduct.
I just want to clarify. Okay, so let's go one by line on the sample code here. So when the builder, okay, that is the cross-chain builder, it starts a batch. In our case, a batch is just a set of function calls that you would like to call on a specific chain. The source chain here is just chain ID number, nothing else, just the simple chain ID number, 1, 10, doesn't matter. The transfer action in the second line is a convenience call for what we call an action. That is, an action in our case is just a wrapper for a method sig, basically a method call inside an Ethereum smart contract. The third line is doing exactly, this is just a sample code, it's doing exactly what the second line is doing. So the function call action is a way to show you that the function call is just an arbitrary call to just a target that is, in this case, USDC address, and the function name of what it does. In this case, the function name should be transfer and not call, but basically this is just an arbitrary way to call an action on chain. It can be any smart contract with any ABI that you like.
I think I explained it before you came.
Okay, sorry.
Yeah.
On slow.
Okay, so I will say, like the A you see, like it can look weird, but the fact that you can name your request, it doesn't make any sense here because you have 2 chains, but you can build arbitrarily complex, nested, looped structures with the SDK.
Anything but loops.
Not very much looped, but like
It's a directed graph.
directed structs, and then you can just select which vouchers go to each batch.
Yeah. And in our case, we just demonstrate one source chain and one destination chain, but technically we allow any number of source chains and any number of destination chains and any combination of these.
One more. We keep saying source and destination when there's an example of two, but it could be a 1, 2, 3, 4, 5 listed again. Someone skipped the line. It can be a complex acyclic graph. So for a single operation, there's a source and a destination, not for the entire graph. I think some of that we covered on the previous time, because this is a batch builder of a single chain that performs the execution and pass a user operation, pass action to them to build so that eventually will create a user operation.
Okay. Yeah.
Okay. No, we don't have slides. I'm not sure we're going to talk about now, but
okay, we don't have an example in this code snippet, but as you can see in the third point, okay, we support runtime vals. Now, runtime vals, what it's supposed to do is basically if you don't know how much you want to send. For example, if you add an action in the source chain that just swaps on Uniswap, and you don't know the exact output of this swap, and you still want to use it to transfer it cross-chain to the destination chain. So what you would need to do is add a runtime var action that basically specifies that you want to take the balance of in your account post swap, okay, after the swap, and then just use it inside a voucher request. We have a sample code for that in our repo that we will show you. It's not in the snippet here.
Basically you add an action that makes a static call and save it into a variable. And then any request, it can be a voucher request, but also any other request can reference a runtime variable and use it. And it's a value that is only exists during the execution of the call. Like usually a balance of, but it can be anything. Any method that returns byte 32 add value can be used in the future functions. Okay, we talked about it. Action is an abstract method call, internally implemented as an encode call. So encode call is very simple for simple functions. It can be more complex than that. So this is a simple action that we showed earlier. It's a transfer action. Gets usually a token, recipient, usually an address, again, can be another multi-chain entity and using the addresses on this specific chain. By the way, I forgot to say, if anyone has a question or something is not clear, please stop me, so we'll be able to clarify. And this is an example of the implementation of encode call. We take your multi-chain entity, you take the address on the current chain, you receive the batch so you know which chain this is encoded. The encoded is on a specific chain, obviously. And then we return an internal function call object, which we clearly understand.
So what you see here is basically the underlying implementation of transfer action, which is basically doing what function call is doing, but instead of having in the function call, when you do add action, when you need to specify all of these fields here, we just added a convenience function in this case, because transfer is so common that it can be used like that. And we have several other conveniences like that, but basically all of them can be used as a generic function call.
Yes, and in many cases, you can see this function. This is the place where we resolve multi-chain entities into the specific chain addresses. We can see that in this example, we actually didn't. The recipient is required here to be a address. It can be easily extended to be a multi-chain object. So you don't need to specify the address specifically when you're doing
you do take in the second line, you do take the token address from others.
Yes, we're doing it for the token, but not for the recipient. Yeah. So the token itself is always a multi-chain. Yeah, it can be. It's a sample. And one important thing to notice is that an action is encoded as a sequence of calls, not as a single call. In many cases, like an action will require, for example, approve. So it is, so you can create an array, return approve this and that token, execute what the execution, and maybe approve 0 to make sure I don't have dangling approvals. And this is a batch that defines what the action I'm doing. If you go in the code later, voucher request is exactly that. Perform an approve and then make a call to the underlying function to do the code. Okay, this is another, we saw it earlier. This is a generic function call name. One thing to know that you specify a target, you specify a function name. You can specify the ABI if you need, and but a multi-chain contract for convenience holds the ABI. So, like this can be implemented. This is a real implementation because my contract can hold its own ABI. You don't need to specify specifically for each call. Okay, now we're getting to the part that we have the execution. The cross-chain executor takes all the batches we created and convert them into user operations. It also takes all the vouchers and validate them on the destination chain they have to make sure that there are providers that can provide them. At this point, if you're, for example, using a token that there is no provider that currently has a balance, it will revert before you even start doing anything. It collects the addresses of all the providers that can provide and put it in the user operation. And create actually the list of user operations to be executed. Everything I said is packed into this single function which is called build and sign. It first builds the list, connect all the chain, collect all this information, and then it triggers the accounts sign. I'm not sure with that. Okay, the multi-chain account, we added a function which is called sign user operations. It signs them all together. And instead, we are defining an RPC call to support it. We worked with Ambuyer. So on Ambuy, it will pop you up, show you all the user operations, so we'll be able to sign them together. And then after you finish to build and sign, the next thing is to execute. Execute is a multi-step operation. It's not that you just wait for it, because at the minimum for transfer, you execute a user operation, you wait for it to complete, you wait for a voucher, you submit the second user operation, wait for it. There are at least 5 steps, and as we know, if anything can go wrong, it will. So you have at least 5 places that can fail. You do want to know where you are, at the minimum, to show a progress in the UX. So we have a callback that gives you all the information you have. The index, you created a sequence of user operations, so it's a sequence number of your batches. Type, the most important, of course, is failed, but we can see internally the other cases, like we created the user operation, we submitted the user operation, we're waiting for a voucher, we just received the voucher, great. Let's continue to the next. You have the transaction hash once a user operation is there, and chain ID. A user operation also contains internally the chain ID.
Dror,
yes.
There is a question? Yes.
Can you give me a microphone? Because I cannot hear.
I just had a question about the cross-chain executor. You're saying each batch is single chain, but you can put together multiple single chain batches to execute cross-chain with the executor.
Yes.
Right.
Okay.
The idea
Like you don't have cross-chain, like the batches themselves are not multi-chain.
No.
No. Okay.
Okay, we have cross-chain batch, which is
Okay.
all the batches, and for each chain we have.
So let's go over the structure again. The SDK has as the main class the cross-chain SDK, which gives you a cross-chain builder. Now, this cross-chain builder you can start with it, like I think you start with start batch or create batch, I don't remember, start batch, and that returns you the batch builder. Now this batch builder you can, for a single chain. Now, so it's two layers of builders. One of them is building the cross-chain batch, the cross-chain operation, and each cross-chain operation has a batch builder that builds for a single chain. Okay, so in this case, this builder is actually the one that is the cross-chain builder. So after you start batch, okay, and you added all the actions to the batch, then you start another batch, for example, for the destination, add all the actions that you want, the voucher request, using voucher from the source, then you do builder.build and sign, that is the cross-chain builder that returns you an executor. Okay, so in this case, you already have all the user operations on all the networks built and signed, and the executor, as Dror rightfully said, accept a callback that right now this callback is very simple, but it can do much more elaborate things, and it actually is missing some fields here for conveniency that we added just for you to be able to have more information. You will see them in our repo. They are well documented, the fields that the callback is getting. But yes, so you have a cross-chain builder that gives you single batch builders, single chain builders that are the batch builders, and they return you each one of them the cross-chain, the user operation, and eventually you have the builder that builds all of them together, builds and sign, and yeah, that's it. That's all.
Okay. This is okay. Some helpers on the multi tokens. I want to show you a demo of this application. Sorry? Sorry, yes.
So if we have like,
Just a second.
in that simple example you showed where it was just like a source chain and a destination chain.
Yeah.
On the simple example you showed where there was just a source chain and a destination chain, you had the like add voucher requests, like you added one voucher. If we were to like have an extra chain in there, you would need to create another voucher for that second chain if you wanted to do something like.
Yeah, okay, so if I'll give you an example. So suppose you have multiple source chains, you can ask for vouchers on all of them, just add voucher request on all of them. And then, first of all, this voucher request is designated for a destination chain. So if you have one destination chain, of course, all of them will be for one destination. You still have to specify the destination for each voucher request. But then on the destination, you can use all vouchers, which is a convenience to just use all the previously requested vouchers. Or you can use voucher per voucher that you're calling. And if you're calling with also multiple destinations, then you just need to specify for each destination the source vouchers that you're using, as I said.
Okay, I'd like to, as an example, think of if you have a blob for all the actions you run on each chain, and then a voucher is the arrow. It's a request on one chain, a destination on another chain. So you can have just two with an arrow between them. You can have three in the list. You can have one that span multiple requests, used on different chains, and collected into one chain or going elsewhere. As long as this graph doesn't create the circles, it's okay. It is okay that the same chain will be used twice. For example, if my flow means move my tokens to another chain, perform an action there, and move back to the same chain, it is possible. It's another batch on the source chain. It is okay.
And that's where you were talking about if you don't know what the amount that is going to be after the chained operations, this is where you can set a percentage with the add variable.
So, for example, if you have, I don't know, if you have a very good aggregator of DApp aggregator, some sort of a DeFi aggregator that you want to use, for example, for elaborate swaps, and you have the best prices for USDC to ETH on Arbitrum, but the best prices of wrapped Bitcoin to ETH on Base, then you can do all of these elaborate swaps in from source to destination, then back to the source, and we don't enforce any restrictions on this. Besides, again, for this graph to be acyclic, just in order for us to be able to resolve it. But that's exactly what we are aiming for.
We didn't say. Everything we do in EIL is the same token. Like you're moving, the token can have different addresses, but it is the same token. You're moving your tokens from one chain to another. We are not handling any pricing, we don't have oracles, because it should be the same value. You can build different protocols on top of that, but when we are saying swapping that, you always go use DEX for doing all those things.
Okay, we don't prohibit sending an asset, one asset to a different asset on a different chain. We just don't natively support it in protocol. So it's not that we enforce that they are not the same. We just don't have any way to know whether they are the same. Okay, so that's why it doesn't.
Okay. And a small thing, like you can actually move this variable across chain using a special key that you can create in like you create a session key in your in an SDK, and that allows us to append not only the voucher itself, but also some extra data. So you can create a random variable and move it across chains and resolve the, for example, the price of a swap on Optimism. You can move this data next to Arbitrum, even if like you didn't know that, and you don't need to use an oracle or message passing. It's just a part of the SDK. Session key. So like
we have session data.
Session, yes. Yeah, session data is the signed data of the session. It's a
session data is this. I'm not sure we'll be able to go into session data. Yeah. This is a sample program that we have. Actually, it's the sample program we copied into the.
So to simplify, I think to simplify the flow, if you guys were in yesterday on any of the talks about EIL, so EIL mostly focuses on 2 or 3 things. One of them is cross-chain asset transfer. The second is multi-chain execution and multi-chain gas abstraction. So in our case, the cross-chain asset transfer is simply add voucher request and use vouchers. This is literally the cross-chain asset transfer. The multi-chain execution is adding arbitrary actions, as we could see, on all the networks. And the gas abstraction comes natively from the protocol, where you pay with the first token on the voucher request for the gas on all the destinations that you're using. So you can pay with 1 token on the execution on all the networks.
Okay. Now, I just want to see if I run this test program. So it starts building everything. This is my account. It created the batches. It doesn't take. It's synchronous. It doesn't do anything. Now it's building the user operations. It's a bit slow, the network, but it works. That's good. It's executing the graph. We are seeing they executed the first transaction, completed the first transaction. It waited for a voucher. The voucher was issued. Now it's executed on the destination chain. It doesn't show much. It would be better if, in terms of our progress.
The demos yesterday were better in terms of what they showed, but this is just to show the
code that runs.
The SDK itself. It's not about the demo.
Yes. And it timed out. Sorry. Never demo online.
Is that CLI example code on the GitHub, or is that on your GitHub?
Yes, so everything Dror currently runs is on GitHub. We have actually other repos as well that we are going to provide you with links for. I'm not sure that they are in this presentation, but we will provide them in our GitHub repos, and you can see all the information, all the more elaborate examples for what we did, and hopefully you can build up on that. And if you have any questions, of course, come to us, ask us. We are here.
We have a demo with React and VM, and we have a CLI demo for like different scenarios.
Yeah. The demo is working both on Sepolia, on Sepolia's networks. I think we deployed on Arbitrum, Base, and Optimism Sepolia, and of course mainnet Sepolia, it's Sepolia. And it's working on our DevNet from Tenderly, thanks to the Tenderly team that provided us with a long-term DevNet that also has more elaborate tracing and all the features that you know from Tenderly.
With the idea with the Tenderly, it's a fork of the real network, so you can use more for whatever.
Yeah, exactly. You can use
something you can't do on.
You can use for example, the Uniswap addresses and Compound and whatnot.
And Stitch is like a full-fledged like DeFi platform working with EIL internally, like just pure EIL. Stitch app, yeah.
The Stitch app, yeah. Yes, it
it is
Yeah,
open
it's open source.
Sorry?
It is not in the Infinity repo. They have a Stitch app repo. I will get the link. We're making sure that it is linked here. Any more questions? If we talked about runtime vars. Let's say that I'm not sure it will work, but sorry, for runtime var, what you do, you make a call to a transaction. Like, I'm not sure that I'll be able to add it here. No, actually, sorry, I'm not.
Don't go doing a sample. We have several samples of runtime vars and how to use them. We don't have to show it here.
Yeah.
But I think that while it is complex because it's a more complex concept here, but it is still relatively intuitive in my opinion.
Yeah, the idea you add an action, the action set var action, it makes a static call and save it into a variable, and then instead of a variable you use runtime var. This will revert if I run it because it is not set, but it will use it inside the execution of the application.
Okay. In the meantime, are there any more questions? Something that you want us to elaborate on?
Hey, thank you for doing this. Can you please show what is like the token file where you get the USDC address from?
Yeah.
Okay.
I'm just wondering, like, in the case when you have fragmented liquidity.
I have here.
The token file is simply an array of.
So it's just arbitrary input, right?
Yeah, it's an arbitrary input.
Yeah. Okay. Thank you.
Just chain ID and address.
Let me go a bit back about an overview of the SDK. There are a lot of things you need to do in order to do cross-chain application, like querying oracles, all the usual stuff you need. The SDK is concentrated on making the actual cross-chain transaction once you know what you want to do. So yes, we do need a set of addresses for tokens, and we assume you have a good source for that, because this is not something we can provide. We cannot even attest that these addresses are correct. But if you specify invalid addresses, like when you create a voucher, when you pass a multi-chain token, you actually say, I'm looking for this token address on my chain, and I'm going to this token address on that chain. This is the value. And if it's a wrong address, then probably no provider will execute it, and you'll time out because it's not a valid. Or if you just like you ask an invalid token, we're not validating the token, but
okay.
So we do assume they are the same address because there is no pricing queries here. So it should be the same token, the same value. So a provider will accept and do it.
Yeah. Okay, thank you.
Yeah, and like to touch on the question about like fragmented liquidity, you will be able to collect your liquidity using the EIL. So it's not like as fragmented anymore. You just create multiple what we call voucher requests, and you have like multiple source chains, just a single destination chain, and then you can collect like 100 different chains into one, and just wait a little bit for all of them to arrive.
Okay. Now, yes, and the SDK right now is mostly the primitives. An example: if you have a fragmented liquidity and you want to use, I want to use my USDC. We can create a set of batches that run your USDC from whatever chains you are and do some operation with that. Right now, it is manually. You need to know on which chain and run a batch for each of those chains to collect it to one chain and do the operation. Like you do it in your dApp. We do want some of this, to have helpers inside the SDK
So
will be done automatically.
actually, for touching the helpers, as you said, this SDK that we are showing, this is the pure EIL SDK that should do the basic stuff, the basic things that we showed you. But there is already, for example, the Stitch demo, the Stitch app that Ophir showed yesterday. They built on top of this SDK another SDK that just wraps and gives you more convenience methods for swaps, for different DeFi actions that you can use, and just as more elaborate primitives instead of just implementing them yourselves. Okay. The Stitch. Yeah, the Stitch
The Stitch
SDK.
SDK.
We'll
find it. We'll send it to you.
Join the Discord and we will share the URL on Discord.
Yeah.
What, we have Discord?
We will have a Discord.
No. Kidding. We have a Discord.
We have an account of such in Discord.
Yeah.
No,
And then like another small thing like
it's technically our organization Discord. We have a Discord, guys.
We have a Discord. Don't worry.
We cannot advertise the
and we also have it already in GitHub. It's just that the Ophir that built the Stitch API, he put it in his own GitHub repo, but that's okay. It's also public and it is accessible by anyone. So we'll just post the links in our GitHub and in our Discord, and you can use that.
Yes, someone behind.
Yeah, sorry.
Here is a Discord link. If I don't know how to put it on the screen. Sorry.
For something like a cross-chain like token transfer, on the destination chain, there would have to be some kind of LP for like providing liquidity on that side,
Okay.
right?
Yes.
So would there be like an LP like fee as well, and something
Yes,
to
as I
take
said, there are
account?
going to be fees. Yes, there is an LP that listens. Everything you see here, there's no server except nodes. The clients we connect to the network. All the communication is done on chain. I request a fee by a transaction, and the provider give it by issue a transaction on the chain, so I can take the voucher. I didn't go into the deep into the flow.
To clarify, because I think it's a great question. There is a fee mechanism that is part of the protocol. It's part of the protocol itself. We just hid this fee inside the SDK because we have, in our opinion, a very reasonable way to adjust the fee. But the way it goes, it is a reverse Dutch auction. That is, the client, the user actually specifies the fees, and the increase in time, the fee, how much the fee would increase in time in case the transaction isn't included. So it can, for example, just include a very small fee for the XLPs, for the liquidity providers, and the fee will increase as much as the user specifies in case no liquidity provider see that as profitable enough for it to include. And it can also include a maximum fee that it will reach. It doesn't matter if time passes, it will no longer increase more. But basically, the user very much controls the fee. Yes, so you ask if there is a way to estimate it. So yes, exactly this is what we do. We already look for previous liquidity providers and see like the average fees that they are taking, and we are taking something a little bit lower than that and post that as the reasonable assumption of what it would be a reasonable fee in our case. Okay. So we put some reasonable defaults, but it is configurable.
What happens if you create a voucher with too much value? Is there a refund mechanism at the end, or like unused voucher amounts?
What do you mean? Okay.
More than liquidity can be provided on?
A voucher is either used or not. Like if you make a voucher request, for whatever amount token. If no one accepts it, you'll time out. You will be able to unlock.
You will need to wait for a timeout, which is about an hour.
Less than an hour.
The SDK will handle it eventually. Right now, it doesn't. Withdraw this amount because it's yours, and to continue without it. If the voucher is used, we showed here on the example of a voucher of a single token, but a voucher can be multiple tokens. So it is either all this voucher is accepted or nothing at all. And so, so there's no unused voucher in that case. There are cases, there are edge cases like a voucher was issued, there was a real voucher, but your transaction that uses this voucher reverted. Now, this is an unclaimed voucher. It was already used, so you cannot claim it on the source chain. The provider can already claim, you cannot get it for yourself. What you can do, and we will do, is do a mechanism that, a fallback that will either, depending on what you want, create a voucher back to move it to the source chain, or if you like, you can continue and create another user operation to run it from the destination chain.
Like the money is never stuck. Like
Yeah.
if your operation reverted, the money is available to you. It's on your account, just on the destination chain. Like the thing you wanted to happen didn't happen. But yeah.
So, at the moment, it is locked, and you need a specific manual API. We do the
It's
SDK
not-
will
it's-
add it so that it will
Okay.
automatically or half automatically will get it back to you.
So, to clarify the flow, when you add a voucher request, it literally calls a function that requests the voucher on chain. This function deposits the tokens that you want to send to the other side in the cross-chain EIL contract. Okay, and this contract is basically waiting for a liquidity provider to call issue voucher. So if any liquidity provider issue the voucher for you, then the wallet is going to take this voucher from the event and post it in the user operation, as we do with use vouchers. Okay, and that will then transfer the amount on the destination chain. Now, if this voucher isn't used, if the voucher request wasn't fulfilled, then it has a very short timeout, and then the wallet just can withdraw it again from the deposit in the EIL contract. So it's not like it's locked only for the expiry of the voucher request, which is minutes.
Any more questions?
Yeah, maybe at like inspirational. Like we expect the wallets to do more and more integration with the EIL. So like for now, the SDK is written for the DAOs, but it's useful for the wallets, and wallets can embed it and like use the features that we are providing. But as time comes, we expect it to be more of a wallet thing to support EIL. And for applications, they may not even like need to like add an SDK, and they will be able to use, for example, like send calls API to just like express their like cross-chain intention and just use that.
No, basically, we do expect that the application will do, of course, will do all the batch building, because this is part of the application, and the sign and execute will be done by the wallet. So once we have that, the SDK will almost stay the same, but we'll use more of the wallet in order to do this stuff. It requires more to define the standard to interaction with the wallet for status, for running the engine inside it. But so right now we are using the wallet only for the signature, the multi-chain signature, and all the SDK is running on the application side. Okay. So we're done. Thank you.
Okay.
Thank you.
Thank you very much.
Yeah.
Another question? Yeah.
So I heard that there was a docs page on a URL that dropped this morning, but I haven't been able to find it. It's not on the EIL/SDK README or repo, but I saw earlier like actual docs from the earlier workshop. Can you put that up?
We do have a docs page.
I'm not sure about URL where it is.
Tom is here, happened to be here. Where is the doc page? Like, what is the URL?
Yeah, the release was yesterday, so like.
Yeah, it went live yesterday night. It's available at docs.ethereum.com. No, docs.ethereum.com.
Like this?
You can open it, I think. You have.
I wanted to get rid of the underline. It's open.
Oh, you just do it.
Yeah. I could also open the Discord now.
Okay, so While the SDK currently looks with very basic building blocks, as we said, like for example, every developer that wants to contribute and add maybe a more elaborate building blocks and maybe use something like what the Teach guys did, that would be awesome for us. We're accepting pull requests for that, and that would also make the effort for the community much better. So if you're using a certain dApp and you're already implementing all of the functionality to actually batch reasonable calls to that DeFi, then it would be awesome if you could also open a PR for us. We will add it as just a native block builder. Yeah.
Tom, do you have any information about the hackathon?
One second, sorry. So we do have another workshop on Friday, the 21st, at 5 p.m. Workshop room 3 for anyone who's going to the ETH Global Hackathon, that is. And we also have a bounty, 3 prizes, 3, 2, and 1K. We're basically looking for projects that will take the EIL SDK and build cool stuff with it and demonstrate what you can have when you have, trust minimized, seamless UX. So yeah, again, Friday, November 21st, 5 p.m., workshop room 3.
Thank you, everyone.
Okay, thank you. We are still here.
Thank you.
Yeah.
Thank you.